Okay, hello. So let's take a look at this sum digits method, which is made to get the sum of all digits in a number. So to test our method, somewhere in the program we're probably going to call it sum digits, and that first s is actually lowercase, pretend. And we'll pass it a number like 175 because we do need one that's at least a little bit long, and pretend that's in a print statement so we can actually see the result. Alright, so 175 is chosen because we won't be able to see it well. If it was a shorter number, we wouldn't really be able to see it. So instead, we want to see with the 3 digits. And speaking of seeing well, let me adjust the focus here. Now I'm just going to be honest with you. I am recording this narration after looking at the video, and well, let's just say this is the first of the recursion videos I did, so just know that. Anyways, so our first call happens with our number in there, so that means our n starts off at 175. So you check 175 first. Now, our base case was if n is equal to 0, and in this case, 175 is our first number. So our base case was if n is equal to 0. Well, n is actually currently equal to 175, which is not equal to 0. So we do not return just yet. Instead, we do a return statement, but it's a return statement with a recursive method call inside. And so we return our number modulus 10, so 175 modulus 10, added with the recursive call of sum digits of our number divided by 10. So the result of which, 175 modulus 10, well, whenever you modulus by 10, you get the first digit of that number. So that means, or the rightmost digit of that number, the thing in the ones place. So modulus 10 gives us 5 for 175, and divided by 10, it gets rid of the first digit and just simply returns a 17. So that's not to say that some digits, so yeah, never mind, sorry. So the result, so then we go ahead and call some digits on 17. That's our next in value that we're using. And just like last time, we're going to check. It is not 0. Not 0. So instead, we return 17 modulus 10 plus, yeah, we have to return it, plus some digits of 17 divided by 10. So when we modulus by 10, we get the first digit, that's 7. And then when we divide by 10, we ignore the first digit, so we just have 1 left over. So then we go ahead and call some digits yet again, but this time with a 1. So we call on 1, that's a 1. It really is, I promise. So we see again, it's still not 0. So instead, we're going to return, I'm going to write it here so I have room. Return 1 modulus 10, which just gives us 1, plus sum of digits, that's what that word says, of 1 divided by 10. That's what that number says, which 1 divided by 10 is just a 0. So we call it on 0, and since we hit our base case, it is equal to 0, we just return n, which is 0. So then we add that 0 that we just got with, because that's the same one right there, we add that 0 to 1, which gives us a 1. And then we add, so we got 1 so far, then we do 1 plus that 7 up there, which gives us 8, and then 8 plus that 5 above it. Why is that happening? Okay. 8 plus that 5 above it, which gives us 13. So that was the result we were looking for. After we add it all up, the 0, the 1, the 7, and the 5, we will get 13. And that's how the sum digits method actually works. So, yeah, that one, you can see it's kind of like the, it's very much like the power in and the Fibonacci programs, because you have this mathematical operation being done recursively. And so the way that works is each time you get a new result for some digits, you just string it along in that operation, adding them all up. And yeah, it also has those really handy features you'll probably be asked about on any AP exam, and it's just good to know. When you divide by 10, you ignore the first digit, and when you modulus by 10, you get the first digit. If you'll remember, this is because whenever you modulus by a number, you get the remainder of a division problem. And if you had, for instance, 175 modulus 10, you would you'd get well, it would go into it obviously 17 times whole, and then have that 5 left over, and that 5 is actually your first digit. So that's a good thing to remember, good thing to keep in mind, very helpful. Alright, well that's what I got for you for this method. Remember, the code is linked in the description. Have a good one.